In this video, we'll be having a little look at data structures. In particular, we'll be looking at arrays, lists, and a special implementation of lists called queues and where they might be used. So, we should already know that we use variables to hold a piece of data in a program. And these variables could be of different types, so it could be of a string, boolean, integer, and then depending on the type of data that it holds, a certain amount of memory will be given to that variable. And you can think of memory in a computer to be a little bit like a bookshelf, a very big bookshelf, with each of the shelves being a single memory location. So if you consider this little diagram, we've got an example of memory, we've got the address of each location of memory, and we've got the data that it holds. So in address 1, 2, and 3, we've got boolean data, and in addresses 4 to 7, we've got the string, which is name. Obviously, it needs a little bit more memory locations to store a string, because we could hold a lot more data in a string than we could in boolean, which is either true or false. Okay, so obviously using just variables in your programs, there's obviously a big limitation to that. So what we have done as programmers is we've developed data structures which could hold related data together. Okay, it'd be much more sensible to do so. And in programming languages, a structure that allows that to happen is called an array. Okay, and an array is declared. We have to say what size it is and the type of data that's going to be stored. And the reason for that is because we need to make sure that a certain amount of memory is created to store that array. So we have to say right from the start, how big the array is going to be, what data it's going to hold. So you can see an example of our memory now. We've got addresses 1 to 6, which are going to hold the array house numbers. We've then got memory 7 to 8, which is just boolean variables, and then we've got memory location 9 to 12, which is another array which holds ages. Now, obviously, this isn't wholly accurate, because if an array was to hold integers, then it would probably need more than one address to hold a single number. But obviously, you get the idea. But the problem is that because we have actually stipulated how big the array is, and we've used that block of memory, we can't actually allow that array to grow over time. Okay, so we can edit each of the values, but we can't actually add anything else to that array. Okay, it's set in stone on the memory. And therefore, we call arrays static. Okay, so they're static arrays. It's a static data structure. So some languages have actually developed lists. And lists are known as dynamic arrays. Okay, they enable the grouping of data just like an array, but it also gives you the advantage of being able to grow in size. And behind the scenes, really, a list is just actually a static array. So here's an example of a static array with addresses 1 to 6, with integer values stored in those address locations. And again, there's no room to grow. But what a list does, or what programming languages allow when you're dealing with a list, is if you want to actually add more data to your list, it creates a brand new static array in another part of memory, perhaps twice the size. Doesn't have to be. Different languages probably do it in different ways, but let's imagine that it produces a new static array in another part of memory of twice the size. It copies the data over, and then it obviously adds in that new piece of data that you want appended to your list. And then there's obviously some more memory locations for that list to continue to grow. So we therefore don't have to declare lists at the beginning, and we can obviously append to them over time. So they are known as dynamic arrays. Okay. But the only problem is, obviously, with lots and lots of data, processing time can be a lot longer if the program keeps having to create new arrays of bigger size. There's a lot of copying of data over to those new arrays. It can take a long time. Okay, so in programming, sometimes we need to use arrays and lists to keep track of ever-changing data in a particularly limited way. So obviously we've got our arrays and our lists to hold linear data. But if you consider when you develop GUIs, so graphical user interfaces, when the program runs, we've got an event loop, and it keeps checking to see whether events have occurred, so whether a button's been clicked or whether a keyboard's been pressed. And as each event occurs, it's really important that we keep those events in order so that we can get them ready for processing. And programming languages have used lists and arrays in a slightly different way. So they actually limit what you can do with a list. So this new data structure, which really is just a list, is limited, and it's called a queue. So a queue really, as I've just said, is nothing more than a list. It's limited to only allowing data to be inserted from one end and retrieved from the other. So a queue is a special implementation of a list. Okay, it's a special data structure. It only allows data to be inserted from one end and retrieved from the other. And they're known as FIFO data structures. The first value in is going to be the first value out. Data's pushed into the queue from one end, called in queuing, and data's retrieved, it's popped out from the other end, and that's known as a dequeue. So here you can see an example. We push the values in, and as new values get pushed, the first value that was pushed in goes higher and higher up that pecking order. And if we want to pop a value out, the first value that was pushed in is also popped out. So it's just like a normal queue that you would have if you're waiting for a, I don't know, to be seated at a restaurant. Okay, if you're first in the queue, you're going to be first out of that queue. Okay, so data's pushed in at the back end, data's popped out at the front end, and there's no ability to insert or retrieve from any other location in the list. So let's see if we can implement a queue data structure in Python. Okay, so in my Python implementation of a queue, you can see that I've just created a menu system so far, and they choose whether to view the queue, to push onto the queue, or to pop out of the queue. And there's three different different functions that are going to be called. So if they pick one, then we're going to call the view function. If they pick two, it's going to be the push function. If they press 3, it's going to be the pop function. So as I said before, a queue is just a list. So let's add a list. So here's my queue. This is all the things I have to do in the morning, and it's in order. And the first item on my list is to wake up, then have a coffee, then have a shower, get dressed, have breakfast, and go to work. So let's try and write some functions which will limit what we can do with this list, because I don't want to be able to append anything to the list in the insert anything within that list. I simply want to be able to pop out an item from one end and insert from the other. So the first thing I'm going to do is I'm going to view the list. So you can see here I've set up a little function, and it's going to look through the list, printing out each item in turn. Nothing crazy about that. The next thing is to push an item. So here it says, please enter the item you wish to add to the queue. And what it's going to do is it's going to append the item to the end of the queue. So it's going to be appended to after this last item, which is go to work. So you can see that if I want to add an item, it is only going to be appended onto the end in this queue implementation. And the last thing is to pop the value out. So here, okay, I only ever want to pop the value out from the other end of the queue. So if I was to write down queue.pop0, okay, it's going to always pop out that 0th item, the first item in the list. So let's see if this works. So if I press run, so press 1 to view the queue. Okay, so wake up, have a coffee, have a shower, get dressed, have breakfast, go to work. Right, let's push something onto the queue. Let's press 2. Okay, so after I've gone to work, what do I want to do? I want to plan first lesson. Let's see if that's been added on in the right location. Let's view it again. Okay, you can see that that's been added on at the end, which is perfect. Okay, so let's imagine that I'm halfway through my morning routine. Let's see if I can pop some things out of the queue. So let's press 3. Okay, it says that I've just popped out wake up, which is good. So that's the first thing done. Let's pop something else out. Have a coffee. Let's pop something else out. Have a shower. So you can see that we're popping things out in the right order. So now if we view the list again, okay, all I've got to do now is get dressed, have breakfast, go to work, plan first lesson, and so on. So that is a nice simple implementation of a queue in Python. Now, let's say we wanted to do this in an object-orientated fashion. This is what we could do. Keep the menu exactly the same, but let's create a class for the queue. So I've created a list as an attribute with exactly the same items as before. And in my class, I've got 3 methods, view, push, and pop. It does precisely the same as the functions before, but obviously this has been implemented as a class, so I need to create an object from the class, and you can see that I've done that, called queue. So now, when the menu is run, I am calling the object queues view method if I have menu option 1, the object queues push method if I press 2, and the queue objects pop method if I press 3. And that there is an introduction to data structures, difference between lists and arrays, and also how to implement a queue in Python.